So imagine you're planning a trip and you need directions, but you also want to know the weather. So normally that means switching between apps, copying addresses, checking forecasts. So to make life easier, we built a focused MCP server called TravAI that solves exactly this. It combines the Google Maps directions with accurate weather forecasts, all in one place for you and your AI agent. TravAI is not a chatbot or assistant. It's a lightweight, reusable tool that any LLM or MCP client can call to handle travel-related tasks. So let's take a look at how it works. You first put your source location wherever you are. And then the destination, let's say we want to go to Zurich. Next, the travel mode, I prefer to go by train. And the departure time, here it is important to stick with the provided format. Let's say we want to go tomorrow, 10 a.m. We submit. And then you get the total distance and how long it's going to take, as well as the fastest train combination. So first we will go from Tübingen to Horb with 7 stops, and from Horb to Zurich. Here we have the map plot, which shows you, okay, from Tübingen to Zurich, the exact route. Close this, and additionally, we have the weather forecast. I mean, if we want to go to Zurich, we want to know how the weather will be. Let's say we stay from the 11th to the 16th. You submit, and then you get for each day all the information, like 11th, 12th, 13th, etc. You get the sunrise sunset times, the temperature range, the overall weather, and the maximum UV index, as well as for each hour from midnight on, you're provided with the temperature, how clear the sky is, the UV index, as well as the visibility. UV index is relevant if you want to decide for a sunscreen, and visibility if you plan to go to a certain view. You can check that. Now I would like to just take a quick look at the code for orientation. So first, we load environment variables using .env, including our Google Maps API key, which powers the directions feature. And then the get directions function here takes a source, destination, travel mode, and departure time. It queries the Google Maps directions API, then parses and formats step-by-step directions. And it, as shown before, generates the static map snapshot using the encoded polyline from the route. And next we have the weather forecast. It uses the Geopy library, and we geocode a location name into coordinates. Then we query the Open-Meteo API for daily, and if close enough time-wise, the hourly forecasts. And then here we decode the weather codes into readable descriptions for the UI purpose, also including UV index, sunrise, sunset time, etc. And here at the end we have the Gradio web interface.